So in this video we're going to continue topic 5.1, the mean value theorem, where we're working on example 4. So for the following problems, read the information given and determine which existence theorem, either IVT or MVT, is appropriate. Then verify conditions to see if the appropriate theorem can be applied. Do not apply the theorem. Typically on the test, we will apply the theorem. These are very similar and usually pop up in free response questions phrased this way. So it'll be like part A or part C or B or something of a free response. There is a typo here. This should have said differentiable. So the function f is differentiable for all values of x. Selected values of x are given in the table above. So they ask a question, or they'll say must be. So the answer to these questions is 100% of the time it's always yes. So we're going to start with yes. So yes, there is a time, but then you have to tell us why. So we're going to start. So there is a time such that so we're looking for MVT or IVT. So is there a time C between 1 and 7 such that f of C equals -2? Give a reason for your answer. So notice, I'm just looking to see, does it match or is it a derivative? It matches, so it has to be IVT when it matches. So it's yes, IVT. Actually, I'm going to do this because I'm going to kind of start the phrase. So yes, f is differentiable. So which implies that it's continuous. So IVT can be applied. And that's all they're really asking us to do, because they didn't want us to go further than that. They didn't really want they just wanted the reason part. Okay, so now I'm looking at B. So B says, is there a time R between 1 and 7 such that, and it's F, should have been F prime of R equals -2. Give a reason for your answer. So we're just basically looking, we know that the answer is going to be yes, but we have to decide if it's MVT or IVT. I notice it's a derivative and it's a function, so I know it has to be MVT. So we're going to say the same thing. F is differentiable, which implies that it's continuous. So MVT can be applied. And we'll make these sentences a little bit more sophisticated as we keep moving through these type of problems and actually go the problem the whole way. So in example 5, very similar to example 4, we're going to not apply the theorem. We're just going to decide which one there is. So for t greater than 0, the velocity of a particle is moving along a straight line can be modeled by a differentiable function. Selected values of v of t are in the table above. Must there be a time? We know the answer is yes, there must be a time, such that a of k is equal to -1. Well, I know that acceleration equals the derivative of velocity. So since I have a derivative and its original, this has to be an MVT problem. So in order to have MVT, I need to be continuous and differentiable. So yes, what is the function? A, or whatever, it's v of t is differentiable, which implies that it's continuous. So MVT can be applied.